We're switching to that second half of chapter 1. We're going to look at sections 4, 5, and 6, and we will test on those 3 sections together. For this week, we do have a short week, so our goal is to get through all of 1.4 and part of 1.5. Right? Complex numbers. I'm going to skip over here for just a sec. Do you guys know what we mean when we say complex numbers? Do you know what I mean when I say a real number? Yes? Our real numbers have a whole bunch of subsets. What's the smallest one? If we just do like 1, 2, 3, 4, those are called natural. Right? Then if we add 0, we've created the whole numbers. Then if we add all the negatives of that, we have what? Integers. And then if we add all the fractions and decimals and all that other stuff, we have rational. Anything that can be written as a ratio, as a fraction. Okay. What if we have things like the square root of 3 or pi? What do we call those? So that's all still real numbers. This is our smallest subset. Then we add the zeros. Then we added the negatives. Then we added all the fractions. Anything that can't be written as that is a separate set, those irrational numbers. But that's all still part of the real number system. Okay? If we add a second box over here that has all of the imaginary numbers, we've created the complex numbers now. So all of this, real plus imaginary, would be the complex numbers. All right? So what we're going to be working on in this next section, complex numbers, we're going to add, subtract, multiply, divide. We're going to look at how we can solve equations that maybe have complex answers. All right? So all of the things that we're going to be looking at will be, will have an I in them. All right? So today's focus is the first 4 operations, add, subtract, multiply, and divide with complex numbers. So I asked you guys at the beginning of class here just to kind of review, what is the square root of 36? Okay. How about this? Negative square root of 64. Yep. And the negative being outside matters, right? It just means we have a negative answer. How about 84? Square root of 84. Okay, so you had to break it down into 4 times 21, and then you square rooted those pieces, and you got 2 square roots of 21. Our next question asks you to add, but they do not match. Remember, we need like radicals. But both of these can be broken down. The 20 we would break into 4 times 5. So when we square root that, we end up with, okay, negative 2 square roots of 5. And then the 45 we could break into 9 times 5. So we're adding 3 square roots of 5, which gets us 1 square root of 5. Yes? When we have variables, split it apart. Deal with the number part. How would we break up a 72? All right. So we end up with a 6 root 2. Okay. How would we break apart an x cubed if we have 3 x's? Yes, an x squared and an x. The x squared would come out of the square root as just an x. We still have 1 left inside. Okay. But in all of those examples, what was underneath the square root, what was inside that radical sign, was positive. All right? We're going to look at what happens when it's negative. So if I have the square root of negative 9, I'm going to break that apart into a 9 and a negative 1, just like we broke 20 into 4 and 5. All right? I'm looking for a perfect square. 9 is a perfect square. It comes out as square root of 9. 3. Okay. How about the negative 1? When we square root the negative 1, we have defined that to be I. You guys remember that from last year? Okay. So anytime there's a negative inside that square root symbol, you're going to have to pull it out as an I. All right, before you do anything. And that's going to affect what we do tomorrow quite a bit. Going back to our definition here, if I is the square root of negative 1, then I squared would be what? Would just be a negative 1, right? If we square both. That means that any I squareds can be converted into negative 1s, so you will never leave an I squared in your answer. You will always convert it. Okay? So we talked about complex numbers, the whole real plus all the imaginary pieces. Our typical complex number has a real part and an imaginary part. So we write it as a plus bi, where a is the real piece, b is the imaginary. That is considered standard form. So you're always going to be asked to put your answers in standard form. So your real piece will be first, your imaginary piece will be second. Some examples, you might have 4 plus 7i, or maybe negative 2 minus 3i. You could even have just 5i. Right? That's a pure imaginary, but it still falls under the complex numbers. You can think of it as 0 plus 5i if you want to think of the real part and the imaginary part. It's never going to be written that way, but if you need to think of it that way, you can. All right, so our first operation is the whole adding, subtracting part. You're going to treat this just like you would adding and subtracting like terms. All right, so just like when our i's were x's. We could combine things that both had an x. We could combine things that were both just constants. So our first example, looking at the real parts, we're adding a 5 and a 7. We can put those together. The real part would be 12. And then we are going to add the imaginary pieces. We have a negative 11i plus 4i would be negative 7i. And again, standard form has real part first, imaginary second. Subtraction typically causes a few extra problems. Students forget they're subtracting, so I would recommend distributing that negative sign. So we have negative 5 plus I. If we distribute the negative, we end up with a positive 11 and a positive 6i. And now we can just add our like terms again. So combining the real pieces, the negative 5 plus the 11 would get us a 6, and the 1i plus the 6i would get us 7i. Okay, I'm going to pause the recording. You guys try the next two. All right, checking your work. The real parts should get us a negative 5, and the imaginary parts here would add up to a 21i. Okay, on our second one, we have 2 plus 6i. We're subtracting 12, and we're subtracting a negative, so we're really adding an I. Combining real parts, you should have negative 10, and imaginary parts, a positive 7i. All right, we can distribute and FOIL, just like we have with regular binomials, monomials. Our first one, we are distributing, so 4i times 3 would get us 12i, and 4i times negative 5i, take it in parts. 4 times negative 5 would be negative 20. I times I would be I squared. But what did we define I squared to be? So if I squared is negative 1, this really turns into a positive 20. Standard form says the real part goes first, so the positive 20 would be first, and then the imaginary part, the 12i, would be second. All right, notice there are no I squareds left in our answer. For the next three, we are going to need to FOIL. First times first, 7 times negative 2 would be negative 14. Outsides would give me negative 35i. Insides would get me a positive 6i. And what do I get for last? We have a negative times a negative. So positive 3 times 5 is 15. I times I is I squared. But again, the I squared is a negative 1, which makes this whole piece negative 15. What's negative 15 plus negative 14? Okay, and then the imaginary pieces, we have a negative 35 plus 6 would be negative 29i. Okay, again, I'm going to pause the recording. You guys do the next two. All right, checking your work. For the first one, foiling it out, we get 30 minus 45i plus 24i minus 36i squared. The negative 36i squared turns into a positive 36. Added with the 30 gets us 66. So we end up with 66 minus 21i. Okay, what happens in that next one? I foiled it out, and the middle stuff cancels out. All right, this is gone. The negative 4i squared is really a positive 4. Combined with the 64 would get us 68. Okay, anybody remember what those are called? When we have two factors that are almost identical except for the signs in the middle? They are conjugates, yes. All right, so just a quick reminder again, all I squareds must be converted into negative ones. We never leave them in our answer. So we've done adding, subtracting, and multiplying. Our last piece is dividing. And we're going to use that idea of complex conjugates. Complex meaning they have the imaginary piece in there. All right, so we are going to have conjugates like A plus BI and A minus BI. And what will happen is that middle stuff will always drop out. Our I squareds will always be able to be converted, which means we just get a nice whole number answer or a nice integer answer. Okay. So if we were to multiply out these two conjugates, insides and outsides again are going to drop out. So we really just have 11 times 11 and negative 5i times positive 5i, which turns into positive 25. With the 121, we'd get 146. All right, how about the next one? First times first gets us, okay, 36. Insides, outsides cancel. We end up with the last term of negative 4i squared, which turns into 4. 4 plus 36 is 40. Okay? So how we're going to use that idea of conjugates. If you look at the last four examples here, you'll notice that there are i's in the denominator. An I, remember, is the square root of negative 1. So think about when we talked about rationalizing denominators before. We could never leave square roots in the denominator. If you have an I in the denominator, it means you have a square root piece. All right, so we have to rationalize it. We can't leave it this way. What we're going to do is we're going to multiply the numerator and denominator by the conjugate of the denominator. So if we think of this first one as a 2i or maybe 0 plus 2i, what would the conjugate be? Yes. And again, you don't have to put the 0 in there. But if it helps you to picture that conjugate, you certainly can. If it was 0 plus 2i, we need 0 minus 2i. When we go ahead and distribute this negative 2i to our numerator, 6 times negative 2i would be negative 12i. And negative 8 times negative 2 would be a positive 16i squared. What about the denominator? 2i times negative 2i. Yes, negative 4i squared. But negative 4i squared becomes 4. And that's why we're doing this, so that we just have a regular integer number in the denominator instead of the I part. The numerator, the 16i squared, turns into a negative 16, and I put that first. That's the real part. And then I have a negative 12i. And your last step then would be to reduce if you can. In this case, we can. The 4 can be divided into both the 16 and the 12. So 16 divided by 4, negative 16 divided by 4 would be negative 4. And negative 12i divided by 4 would be negative 3i. Just make sure that you reduce both parts, because that 4 really is being divided out of both the real and the imaginary piece. All right, for our next one, what is the conjugate of 3 plus 2i? All right, 3 minus 2i. We have to multiply both numerator and denominator by that. Distributing in the numerator, the negative 5i times 3 gets me negative 15i. Negative 5i times negative 2i is 10i squared. How about the denominator? Okay, first term would be 9. Insides and outsides drop out. Last term becomes negative 4i squared, which really is positive 4. 9 plus 4 is 13. Rearranging the numerator so that the real part is first, the 10i squared turns into negative 10, and then we have a minus 15i. This one can't be reduced. There's no common factors in a 10, a 15, and a 13. Okay. All right, let's try one more. The conjugate of 4 minus I. Good. So in this case, we have to FOIL both the numerators and the denominators. Numerator, if we FOIL it out, 5 times 4 is 20. 5 times I. 4i times 4. And 4i times I. Denominator, 4 times 4 is 16. Insides and outsides drop out. And negative I times I is negative I squared. Right? Converting our I squareds, in the numerator, we end up with this being a negative 4. Added with the 20, I end up with 16. My imaginary parts can be added together as 21i. And for a denominator, the negative I squared turns into a positive 1. With the 16 gets me 17 for a denominator. And again, we have no common factors in 16, 21, and 17. All right, I'm going to pause the recording. You guys finish the last one. All right, looked like when I walked around, you guys were getting this correct. Any questions on adding, subtracting, multiplying, or dividing complex numbers? Your assignment then starts on page 142. You're going to do 1 through 28, 55 and 56, and 78 to 80. Make sure you're showing work, not just doing things in your head.